Well, in this lecture, we'll learn about the zeros method, ones method, and the range methods. If you have already watched the NumPy section, then this lecture will be a little bit easy for you. Well, using the zeros method of TensorFlow, tf.zeros, we can create a vector of any length. All we have to do, we have to pass a length here. Let's say we want a vector of length 10, so we are passing 10 here. Let's name the variable vector, assign it, and execute it. And if we print it, then we will see a vector with zeros only. Great, we can see it. And we can see the default data type of zeros method is float 32. And we can change it using the dtype property, or we can say the dtype named argument. So dtypes equal to, and we can say int 32, and we have to use the tf.in32. Execute it. Okay, I misspelled it, so let's correct it, run it again, and check it again. And we can see the data type is changed. In the same way, if we want, we can create a matrix using the zeros method. So tf.zeros, and inside the method, we have to pass the shape. So either we can call the named argument shape equal to, and pass as tuple. So we want a matrix size of or shape of 2 by 3. Assign it in a variable and check it. Great. We can see a matrix of zeros with shape of 2 by 3. Well, if we want, we can remove the named argument shape, and simply we can pass a tuple value for the shape. Let's say if we want 5 by 6 shape, so there will be 30 elements, and we know that. Awesome. Now what about a tensor? Yes, we can do that. So tf.zeros, and here we are saying there will be 2 arrays inside the main array, and inside every array there will be 3 arrays, and inside all these arrays there will be 4 elements each. So we are saying there will be 2 arrays inside the main array, and inside of those 2 arrays there will be 3 arrays each. So there will be 6 arrays for holding elements or values, and inside all the 6 arrays there will be 4 elements each. So let's assign it in a variable, name it tensor, execute it, and check it. Awesome. We can see there are 2 arrays inside the main array. So this is our main array, and every of these 2 arrays there are 3 arrays. 1, 2, 3. So 2 multiplied by 3, this 2 multiplied by this 3 is 6 arrays, and inside every of these 6 arrays there are 1, 2, 3, and 4 elements. So 6 multiplied by 4 is 24. 6 multiplied by 4, and 6 arrays multiplied by 4 elements is 24. So if we check the size, tf dot size, it must be 24. We can see it's 24. We can also count it here. What about the shape? Tensor dot shape. We know the shape will be 2 by 3 by 4. Yes. What about the dimension? We know it's 3 dimension. First dimension, second dimension, 3 dimension. Okay. Tensor dot ndim, number of dimension. And we can see it's 3. What about the rank? tf.rank? It also should be same as ndim. So tensor, and we can see the rank is 3 because its dimension is 3. Now we can do the same things using the ones method. So we can say tf.ones, and here we can pass the shape, let's say 2 by 3, and specify the data type if we want. Let's skip for now. Assign in a variable and print it. Okay, double E, let's execute it again and print it. Can you guess what will be the output? The output will be a matrix 2 by 3 with value of 1 only. Yes, awesome. We can see there is a matrix with shape of 2 by 3 and with ones only, and its default data type is float 32, and we can change the data type using the dtype named argument. Not only the matrix, we can also create the vector and tensor using the ones method. So let's try a vector. Ones vector equal to tf.ones, and as usual we have to pass the number of elements we want inside the vector, only the length of the vector. So tf.ones, and the length is 10. And its size or its length is 10. So we can check the size, tf.size, and we can see the size is 10. What about a tensor? Let's try it. tf.ones, and here let's pass the shape. There will be 3 arrays inside the main array. Every array will have 4 arrays, and every array will have 5 elements. Ones tensor, execute it and print it. Awesome. So there are 3 arrays inside the main array. Every array has 4 arrays, and every array has 5 elements. Great. Now let's look at the range method. tf.range, and let's try passing one argument only. Let's pass 10 and see what happens. We can see it's executed. So let's print the vector, range vector, and we can see it has created a vector with 10 elements starting from 0 till 9. So the value we pass here as argument, it will count up to, not including. What about we pass 2 values? Okay, if we pass one value as argument, then it will take as up to. It will start from 0 and go up to and it will create one vector. But if we want, we can specify both the starting and the ending value. So we can say start from 0 and go till 50. Executed and executed. We can see it has started from 10 and counted till 49 because it's up to, not included. And at third param we can say how many steps we want to skip. Let's say we want to skip 5 in every iteration, or we can say we want a gap of 5 between every second value. So execute it and test it. We can see it has started from 10 and there is gap of 5 between every second value, and it has printed up to 50. So if we make it 51, then we can see 50 here. Execute it and run it, and we can see this. Well, using the range method of TensorFlow, we can only create vectors. We cannot create any tensor or matrix using the range method of TensorFlow. That's all for now. Let's learn something more exciting in our next lecture.